We are here. And some, some level and we will have to overcome problem to stabilize to help really to the next the lesson from the ResNet. Yes, sir. As a human, we don't have it today. So let's now quick remind what you remember from all this architecture. What is the name? Oh, that's it. don't think so. It will for 64. Right? I have this from both are colors. I like to draw that. Okay. How we can specify user. Next one. And the third one. I will. So please kind of can combine them. You have I will I want my vertical higher intensity energy for those who and then but uh you know first second one so for example for uh, so, um, uh, how many how to split it on small chunks as you see children initially it begins to balance itself, then it runs okay, that's batches, like small amount of and constant memorizes maybe batch. Also we use batch normalization, which also advises training. So this was regarding the convolution. Any questions from that? So now you perfectly know what convolution layers do. And this gives us a lot of possibilities to classify, to size, generate information. Let's proceed with our today's lecture. So, from Or you can read it, but basically you want the one, but if it wouldn't be one by one, for example, by two, uh, channel count by so is it clear why we use ResNet connection our 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 goal? Yes. Can I ask questions? Yeah, yeah, yeah. Previously, I see 30 much more. Of the one. Are those terms clear? Or you have any other questions regarding convolutional method? Absolutely. Basically, practice compress region to reduce the size of We will have our coding time. I will publish. No, it's not such a big deal. I will assign. I have opened the template. Please open it and be ready. Our current work. Open the. I will open the pie chart. So everyone have the code. Everyone open the PNG. No? Okay, two more minutes and then we will start. Slowly we will start. Mhm. First question, to see the code. Well, already zoom it. More? Okay. So if you have opened the code, we have imports, we have matplotlib, some global variables, learning rate, batch size, max length of the dataset, train test split, and the device which we are using. If you have CUDA, you will use all the dataset and utilize the GPU. We have the dataset class, we have train test split, we have for debugging did it now. We're creating the data loaders, train shuffle true, test shuffle false, because we want the same results on the test set each time. We have dense block transition layer, DenseNet. It will be our second part of the lecture. And we have res block, ResNet, and print model size, which is not current. Metrics, main for loop, x, y, model forward. We have loss function, which is cross entropy. We have small if that is going. We have and data print. So data which we visualizing for us to understand the results. So yeah, that's it for our code. Now let's proceed with our res block. If you will look in the image, we have convolution layer 1, convolution layer 2. Let's create them. So we have self conv1, which is equal to storage and then conv2d. Then we have in channels equals out channels equals. We have kernel size. We have stride, which is the step of the window of the convolution window. We have padding and we have bias. So all those variables we need to specify when we are dealing with the convolution layers. So bias. Yeah, but if you want added your model. In the more deeper models, it's just yeah. Okay, we have our in channels. We have our out channels. We have our stride. Then we want kernel size. Kernel size is 3 by 3. It blames us, yeah, that we should go tuple. So not stride, but stride. Just to obey the rules and have less warning. We have padding, which is same window, 1 by 1. And bias false. So we have our first layer. Let's create another one. I will copy it, copy paste. So let's implement the changes. So now we have in, out. No, because we are not creating the torch sequential. Yeah, so now we are only assigning it to variables, so we do not need a comma. Okay, so something happened. It suddenly stops to oh, now it is. So we have conf2 with the same kernel size, same, but only matters is that output, that in channels is out channels and the out channels are out channels too. So this is our 2 layers of the convolution. Then we check out, we have batch norm 1, batch norm 2. So we need additional self bn1, which will be torch, and then batch norm 2d, which have num features, epsilon momentum, blah blah blah. We do not need that. So we have out features, and you can use Ctrl D to duplicate last line. Ctrl D, you have batch norm 2. So we have defined our main elements. Is it clear? Is it done? One more moment. Because we have 2 convolutional layers. So basically, batch norm helps. But usually, yeah, you use some kind of visualization after the convolution. All that you need. I will give you 4 minutes. Start please to code the forward loop, and then I will help you complete it. Wait 1 moment, but they are already there. Yes, please. Right. Like first one is convolution. So self conv1, so output x, out to be equals self conv1 forward x, first block, for example, this one. Then you need to add rel. Then you need Okay, I will slowly proceed with you. So we have our first layer, so first convolutional layer. Okay, we have then relu, so functional relu from out, and then we have our batch norm. So out equals to self, b and 1, forward, out. So we have completed this part. Then we have another convolutional layer. So it is a functional, so it is from the import, yeah, torch functional. So basically, why do we use function? Want the rel. Or if we will to create the sequential, we can also use, for example, you do not need to write that, but self rel1, for example, and add it as uh, rel like that. You can also use this one, but it doesn't have the learning parameters, so we do not. So we just operating with the functional. Okay, after the first batch norm, we had our second convolutional layer, second conv. Now, what we have now? We have summation, so we need to implement this skip connection. So how we will make it? So everyone have this small part, yeah? I do not hear. I only hear. Yeah, yeah, yeah. If something isn't working, please ask. So we will everyone be on the same track. Okay. Now let's get back to our init method. We will define self variable, private variable, is bottleneck also. So basically, we define the variable that is required to the bottleneck layer. So when we will define our layer, it wouldn't be bottleneck. So it expects to have from the same image, so the same field channel count to the same channel count. But if we will have bottleneck, we will have from one channel count from the bigger, smaller amount of channel count. So the bottleneck changes the size. And what are the rules? So if our stride is not equal to 1, so if our stride is already 2, that means or when in channels is not equal to out channels. So that means that we want to have a bottleneck. We want to reduce the size of the feature maps. Then we define that our self is bottleneck is true. Yeah, we have a bottleneck, and we want to create this shortcut. This shortcut is not from here, but from here. This one. So we need this one, this small 1 by 1 convolutional layer. So self shortcut is equals to torch, and then conv to d. I will copy this one, paste it inside, and let's now change. So we have in, out channels, kernel size will be the kernel size will be 1 by 1. So we are not reducing it by using kernel, but we are using it by stride. And padding I guess was manually 1 by 1. And padding by the default is 0, so we can delete that. Control A, Control Alt L. So we have implemented the shortcut layer. So we are not decreasing size by using the kernel, but we are decreasing size by using stride. Okay? Not okay. Or is okay? Decreasing. Stride is a step. Sliding window for the kernel. We don't use the kernel to reduce the image size, but we still use it. Yeah. So basically how much we need to move our window by the image. I can have convolutional stride padding. Small. Can we have if? So this is basically by 2. You see it makes step 2. Stride 2. And then it will be again stride 2, it will be the last one. It skips element inside. Might be this one. This one is padding 2 and stride 1. It goes 1 by 1. Then we will have padding 0 and stride 2, and it will go bum, 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 bum. It will skip some elements inside. Okay. Do not remember. But yeah, this is. If you will remember the name and send me afterwards, I will Google it and check out. Yeah. So okay, we have now our conf batch norms. We even have a shortcut now. So let's proceed with our forward loop. So now we need to implement the bottleneck layer. So if self dot is bottleneck. So if we are here, and if it is bottleneck, so we are reducing the image size, we need to have a not our residual, but our output to be equal to self shortcut forward x. So this is our bottleneck. Then we need to add it to our previous one. So out plus equals output. Might be just for the naming convenience. Let's change output to residual. Let's change it to residual just to not. Check out, please. I have a X here previously, so check out that you have output. So you're using X output, 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 output. Now we created we are here. So now we need to use relu and the last batch norm. So we will have out is equals f relu to out, we need to use our batch norm. So out equals self en second dot forward our out, and we will return it. If you can click Control and press on the F, and it will open the code of what you have. So basically, you're using the So you're basically using not like we can use this res block as the already implemented one res block, or we can use functional and write it down by itself. So basically, in the terms of our project, we can use res block as, for example, torch and then res block, or we can use an implemented fall by ourselves, and it will be as functional, basically. So you have your sigmoid function, but inside of the sigmoid, or let's see our convolution. So we are using torch and then conv 2D. If we will go inside, we will have init conv forward functional conv 2D. If we will go inside, it will already have the function inside of it. So we're basically going from the high level. So this is high level, and functional is low level. So as you see, we're using functional only for rel. So we do not, if we, so we can use, do not write it self, no. Because if we are using the sequential, so for example, layers, it would be torch, torch, and torch, and sequential. Then we would have torch and conv 2D. Then we can have comma, torch, and then relu, blah blah blah. But since we are not creating the sequential itself, we do not need that. We're utilizing the already ready function. Yes, because you do not need the relu as the variable because it does not contain any learnable parameters. So that's why we are not using as the same. So we have conv, batch norm, and then we do not use rel1 equals torch and then rel. So we do not do like that because the rel itself inside is just the mathematical operation just forward. By using like that, we can print out at any moment which size of feature map do we have. So we can easily trace all the layers. But if we are building it inside the sequential, we are like a one big sausage. We have only input and out. We cannot decide. If we can, yeah, we can build our own print layer and like do the same thing. Init, forward, blah blah blah. So it's just a bit more complexity increase. It's better to use like we are like conv, but you know that you cannot build the large models only by using private variables. So you cannot print information what is inside this information. You can do it, but you need additional layer, like print layer to do this. So you just cannot go inside and see what size of feature map you have, or blah blah blah. You name it. So this is just for the debugging complexity or debugging purpose. So I will, let's try to test it just for fun. Let's do me one moment. Like this one. Yeah, residual. Yeah. Ah, no, where? Ah, you mean this one? Yeah, because this was output. So I changed it to residual, not to make clear with with this out, so we do not have out and out, like basically the same thing. Yeah. So yeah. So let's create, or you can keep it torch uh, once shape, for example, 1 3 28 28. Then let's create a layer which would be equal res block in channels would be equal free, and out channels would be equal free. And let's print layer forward dummy and exit after. And if we will run it, have the information. So our layer is working perfectly. And we can even print out the shape, not just the output, since we are not interested in the shape is the same. And if we will change it, for example, to already 4, so input channels is not equal to output channel, so we will reduce 4 by 20. We need to let's try to the size and I messed up somewhere. No. In channel something. Okay, this one seems clear. Just my mistake is entered. Okay, so we do not need that. Our layer is working. I will now post it in the Jamboard. So anyone have the res block implemented. So everyone, yeah, and everything is pretty much clear what each part do. I will put it inside the Jamboard in 1 minute. Yeah, no questions. Res block is implemented. Implemented. Yes. Yeah. I do not have it yet. We will now build the model, and then I will just messing around for the answer. So okay, I will add it to Jamboard, but till that time, please try to implement the 18th version of the ResNet. So basically, we can use 34, 50, 152 layers, but we will use 18 now with the small modifications. So first of all, you will have convolutional layer, which is 7 by 7, or you can use 5 by 5, 3 by 3. Let's use it 3 by 3. Okay, 3 by 3, yeah. I need 3, 3. 3 by 3. and then use block, block, block. Pretty much adjust only the, and you won't have the 1,000 classes. You will have how much we have inside. So I don't know how much classes we'll have, like n, n softmax. So I will give you 4 minutes, and then I will go with you. Yeah. Uh, or stride one. Yes, stride one. There was in, out, stride. So you need to specify those three parameters that you have when you're calling ResBlock. Yes? Uh, add, I will add the
the code to the Jamboard. Then I will catch you up. So we have ResNet, and we need our ResNet. Okay, we need self on 1, 2, 3, channels, options, size, adding, right, bias, stripe, 1, yes, 1, out channels, in channels is 3, and out channels, let's for example be, we have from 3 to 8. Then, since we have our self-conf, we need a batch self bn1. So torch, and then batch number 2. Since we have 8, we have some features 8. Or let's create it as a variable so you can modify it afterwards. So now wait. Another time 8. So we have first layer of our model. The same as channels. I just named it. Like you can name them in channels or yeah. Basic channel. Our first and we have our, let's check it out. We have our 2 identity box. So we have self identity 1. Let's name the press block, in channels, out channels, stride. We won't change the stride. So we have 8. Do you want to create it reusable? So if you change the in planes, it will change the whole structure, or we will hard code it? Not hard coded. So then we will have in, and copy our in planes, planes. So basically we go 3, 8, 8, 8. We need to duplicate it. So we have 2 identity blocks. So basically the same. identity 1, identity 2. We need afterwards, as we here we have two identity blocks. We have dimension reduction from 28 to 40. So it is our self bottleneck one. I will separate it, which will be res block, but in channels, out channels stride, in channels would be self planes, out channels would be 2 times self plane and stride 2. So there were, yeah, it was using stride 7, and you see it goes from 112 to 56. It reduced the size of the image by 2 times. Eventually come with a I'm not finished with the ResNet yet. We need to finish ResNet and then DenseNet. So we will. Okay, we have 7 minutes left. Let's finish the initialization, and then you can go. Okay. So again, we have our bottleneck. Then we need one identity. So self identity 3 equals. I will copy paste. So you will have 2 times planes by 2 times planes. So if those self in planes and 2 by is confusing, please use just manual like 2, 8, and so on and so on. You were silent and one answered that he wants to make it reusable. We are making it reusable. So next time you will appreciate your votes more. Bottleneck identity, bottleneck identity. Then we need again bottleneck. Right. One moment, please. One moment. We have 2 times. Question. further left. So we have our next one identity. So it would be identity 4, 2 times 4 times 4 times. Yes. Then we have bottleneck layer 3, 4 by 8, 8 by 8, identity 5. So it's just a Lego. Comprehend it as a Lego. You're basically building the model using all the code that we have earlier implemented. So we have identity 8 times 8 would be 64. The output would be 64, and we have our self-linear layer torch, and then linear, and in features I said in features would be 8 times planes, and y out features length of dataset full dot labels. I will go up a bit. So as soon as no question, you can go enjoy your meal. in mark
If you uh, minimize minimize
common with what? 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 Now, things.